We had just talked about systems thinking, started on the theory of constraints. And we have this wonderful video that comes to us from the theory of constraints, something association. I didn't make it. I can't do graphics this well, as you all know already. Basic theory of constraints, the system, the throughput of the system is equivalent to the constraint within the system. In this case, each of these 5 stations has different capacities, daily capacities. The third one happens to have the lowest capacity, which is 10. We go through day 1 and we simulate what happens, and you see that the amount of throughput in the system is equivalent to the constraint. This is pretty powerful. You can see that the people downstream are not very busy, and this poor guy on station 3 is really working hard. So anyway, you get the picture. Theory of constraint says if there weren't a constraint in the system, we would tend towards 0 or infinity, meaning that if there were no friction in the system, this comes to us because Elliot Goldratt was a physicist, not a business person. There's 5 focusing steps on theory of constraints. You will have a constraint in the system. Step 1 is identify it. In this particular example, this is obviously a simple example. We have to use simple examples sometimes because of the complexity of what we're doing is so you know, again, we're just showing something that's easier to understand the concept. If you were actually doing manufacturing, it would be pretty easy to find the system constraint because you would see work piling up as it does in this particular example. But you don't always see that in knowledge work because knowledge work, a lot of times it's invisible because we have to make a physical manifestation. That physical manifestation is the product backlog. And without having a physical manifestation, how are you going to find the constraint? I think it would almost be impossible. The second thing about constraints in a complex system is they're not as simplistic as the example, and they have a tendency sometimes to move around. So, but regardless, you will have a constraint in your system or a series of constraints in your system. You need to identify them. And identify the right one, I guess, would be another thing that would be important to do. The person who creates 16 widgets is a constraint, or a future constraint or a possible constraint, but not the constraint in the system. So making any changes to stations 1, 2, 4, and 5 are not going to make any change to the overall throughput of the system. The next thing is we got to come up with a plan. Now, again, the manufacturing example is pretty simple. What's my plan? Okay, well, maybe I add a second person to station 3, right? That might be the simplest thing. Maybe I slow down the stuff coming in stations 1 and 2, right, to match the constraint in the system. Maybe I find a different way. Maybe I invest in a process that automates 3, station 3, and therefore increases throughput. Whatever I do, I need to just make some kind of decision on how to exploit, and that's the word they use, exploit the system constraint. Once I do that, and this is the important piece that seems to be forgotten in a lot of what I do. You need to subordinate everything else to the decision that you've made. What does that mean? That means basically we need to focus on this thing, because focusing on everything else is not going to help us at all. Focusing on improving stations 4 and 5 is not going to help us. Focusing on keeping people on stations 4 and 5 busy, right, because the one guy's reading the paper because things are slow upstream, it's not going to help us, right? So we need to make sure that we actually focus on doing what we said we're going to do, and we shouldn't be, distracted by making other decisions, which companies tend to do. Basically, don't do too much. Just focus on this thing. This is the asymmetric payoff we're looking for. If I increase the ability to move things through station 3 by 50%, I've increased the system by 50%. If I increase stations 1, 2, 4, and 5 by 50%, I have done nothing to the system. So let me not get distracted by trying to improve 1, 2, 4, and 5, right? 4, do it, fix it, right? Now I've got the constraint, I've done whatever it is, I've decided how to do it, I've focused on actually doing it, I've done it. And then step 5 is really simple. Look, once you relieve one constraint, there's going to be another constraint, because that's how systems work. So I need to, again, go back through this cycle. And you notice that, almost everything we keep talking about is cycles. We keep wanting to do things in straight lines. Everything is cycles. It's feedback loops. It's cycles. It's continuous going through, and then we got to go back again. So pretty simple, these 5 steps. The reason that this is important to me is because it's simple, right? It's a simple idea in a complex world that will really, really give us a huge return on our investment if we know what we're doing, if we focus. Let's say I have a Scrum team that's not performing well, and I go in as a coach and I increase their throughput by 50%, right? What has that done for the company? If it's not the constraint, it's not done anything for the company. You see what I'm saying? So in lean, we talk about anything that doesn't lead us to the goal is waste. So all of this stuff we're putting in to fixing all the other things, I'm not saying it's there's no bad or good in here. It's just maybe will have no effect whatsoever on the system. We need to put the effect where the effect is needed. Anyway, let me move on. What are the implications of this? Because this is the real interesting thing. I mean, you look at again, it's the different lenses, man. Once you see the world differently, it's really hard to see it the same way again, right? And it's almost like, wow. I was a child before, and now I'm now I'm a little more mature because I can see things differently, right? That's the way it is. I mean, because when we look through the world with a child's eyes, it's nothing wrong with the child. It's just the child hasn't seen what we've seen, right? That's the value of experience. Systems thinking above all else. If we're not using systems thinking, if we're not understanding theory of constraints, if we're not trying to apply theory of constraints, and I thoroughly admit it's messy in a complex world to try to apply this. And it's not easy. But again, I've never asked for things to be easy. I just asked for it. Is it worth it? Where should I put my energy? Where should I put my time and energy? If I'm going to do something that's difficult, I should probably do the thing that's difficult that's going to actually make a difference. This makes a huge difference. It's easy to show. It's easy to prove. You want system optimization rather than local optimizations. So we started, I think, in day one. I talked about what are we here for? We're not here to try to say that one view is right and one view is wrong. There's different ways of looking at the world. Some are more effective than others, and that's a big difference, right? And we need to take the things that are effective and we need to apply them. But we also have to understand that we cannot optimize local pieces of a system and necessarily will that lead to optimizing the system. This is what Russ Ackoff was talking about. We cannot just take and apply willy-nilly improvements throughout the organization. Because if we're improving pieces of the organization that really don't lead to the bottom line change, what good have we done? In fact, sometimes when we optimize pieces of the system, we do so at the expense of the system itself. So by optimizing a piece of the system, we've actually decreased the ability of the system to deliver value. I know that's counterintuitive and it sounds strange, but the complex world is counterintuitive and strange, right? We need to always keep stepping back. Right? This is what Senge was saying. Step back. We need to step back and we need to view it. We need to view our world. We need to view our companies. We need to view our systems at all kinds of different levels with all kinds of different lenses to understand the system better, not just the pieces. This has huge implications for human resources, which I would say, I think I mentioned before, or maybe it was somewhere else, that there are two places that a coach probably can do the most help within an organization. Two constraints that are general to most organizations that I've worked at. And one of them, the first one that I see all the time, is human resources. Who do we hire? How do we hire them? How do we apply them to the job that we do? How do we incentivize them? Right? I think we do such a poor job of human resources. We should just call it, something else, like legally keeping the company out of trouble when it comes to people. But that's a long title. So human resources closer, but that's what they do. I mean, why do we, I was thinking about this the other day, I think just yesterday, why do we continue to have people, and no offense to any of you if you have this job, called recruiters? These are the people who know the least about the work that's being done. Why are we not recruiting people from people who know what the hell's going on? Because to me, it gets watered down. And by the time you get to candidates, yeah, you're going to pick the best candidate out of the 3 that were the 10 that they gave you. But they might not have been the best 10. Anyway, I got a lot of problems with human resources. And this does make a difference. As I was saying, the one company I worked at, they wanted to hire more developers. Developers are great. I love them. But that wasn't the problem. That wasn't the constraint in the system. And the problem with hiring developers is they're expensive and they're hard to find. And I could have hired somebody who's expensive, and I could have spent a lot of time and effort to get them on board, and it would have made 0 difference because it wasn't the problem. And it was a very simple view of theory of constraints that would allow me to see that. What is constraining the work in the system, right? It wasn't software developers. We need to make sure that we have a flow-based product management as opposed to a project management philosophy. I have a lot of discussions in my day job about this. There is a difference between how we manage projects, which have a definite beginning, middle, and end, and products which never end. They're always with us. If we try to manage them the same way, we got a problem, right? We need to look at the entire system. If I manage a project like a product, I probably got a problem. But I don't see that happening. What I see happening more often is we continue to manage products as if they're projects. That's a problem. I said there's 2 places where Agile Coach would probably do the most good, because these are probably the 2 biggest constraints within the systems I see, one of them being human resources, the second being finance and accounting. Why? Because money is an incentive. And how we use money and how we incentivize people, right, makes a big difference. We're going to see that actually shortly when we have the Cobra effect, and we have some discussions on incentives from Charlie Munger. So cost accounting is what most people use. This is where I'm going to cut some corners and not go into detail like I usually do. Most companies use something called cost accounting. And cost accounting doesn't give us an accurate picture of true accounting because it doesn't take into account the constraint in the system. It assumes that the cost as goods move, or in our case, ideas, since it's knowledge work, move through the system, are uniform throughout the system, but they're not. The constraint has a huge effect on what we're able to produce, right, on a minute, daily, hourly, daily basis. And cost accounting doesn't take that into account. And it causes us to make bad decisions, right? If we do throughput accounting, we account for the fact that we're only moving 10 widgets through the system in the example that I showed you earlier. If we're doing cost accounting, we're just taking the average cost of each one of those stations. It's not the same thing, okay? I don't want to go into the details because I don't have time today. If we have time at the end of the class, I'll go into it, but I think I need to cut it. But I had an example of throughput accounting, and I'll put this up here, obviously in the presentations and recordings for people who want to go over it. And you can do a Google search on throughput accounting. It's just more accurate, even in manufacturing. There's very few companies doing it, but I read somewhere that there's a couple companies that are doing throughput accounting now. It's a much better way of doing accounting. Going back to this thing, here's one of the problems with cost accounting, without going through the laborious example that I usually go through. Profit is more important than cutting cost. So how much profit can I make? Well, if I'm only producing 10 widgets, and cutting cost of the widgets doesn't matter, right? What I can do is how can I move more widgets through instead of cutting the cost? How can I be more efficient or effective in the system? When we go to a cost-based system, and cost becomes the key, like a lot of places they'll say, well, I'm going to do cost plus X% because I need to make X money. It doesn't take into account the value of the goods produced. That's the problem with it. It only takes into one side of the equation. What does it cost me to produce it? So I'll tell you who gets this very well is Apple. I got an iPhone. The iPhone and the Samsung phone probably do almost the exact same things, but people pay more for the Apple phone. Why? Because they perceive that there's more value. What does Apple charge for? Apple charges for value, not cost. They have some of the highest markups of anybody. They charge for this thing that they call value, and people pay for it. Sometimes people, here's a funny thing. I just got done reading a book about how people are fooled in finances. It's one of my favorite subjects. And one of the things that it's easily fool people is if you want people to think that you have a higher value good, you charge more money for it. When I was a consultant, I was one of the cheapest consultants. I couldn't get any business. So I raised my rates and I got more business, right? When you use cost accounting, you don't take into account the more accurate way to allocate costs, which is through the throughput of the system, which takes into account the constraints. So you can come up with some strange numbers and make bad decisions. Cost accounting incentivizes large inventories. Inventory is a liability. You shouldn't keep inventory. And as I said before, pricing of products should be based on value and not cost. I want to go into Cobra effect because it's kind of fun. What happens when we don't apply systems thinking? And you can come up with all kinds of examples, but I got some fun ones. I think they're fun. We'll see. Maybe you won't agree. Oh, I forgot to say, a trigger warning, watch out for the cobras. So we have cobras and rats. If you don't like cobras and rats, you might want to close your eyes. So I want to tell a little bit story about getting rid of cobras in India. Some of you might have heard this story before. Back in the old days, they had a cobra problem in one of the major cities in India. This is back when the British, during British colonial rule. So instead of thinking through, this is my idea of systems thinking is these different lenses and different ways of looking at things. They didn't think this through. What they said is, hey, we're going to come up with the simplest and first thing that comes to mind, and we're going to use that. So this is another way incentives don't work well sometimes in a system. They said, hey, what we're going to do to get rid of cobras in India is we're going to pay you money for a dead cobra, right? So it sounds good on the surface, right? I got a cobra problem. People go out, kill a cobra, bring in a dead cobra. I'm going to give you money. But again, they didn't think it through, right? So I know I can always see, I'm always looking at the people when I go into this, because I'm looking at those with devious minds whose wheels are turning already. And they're saying, okay, how can I exploit this system? Well, maybe you're not as devious, but maybe you are. What happened is people started breeding cobras, right? Pretty simple. I start breeding cobras. I feed them. I take care of them. They get big enough. I kill them and I bring them in and I get my money. There's a problem with that though. Oops, I don't know how that happened. Cobra again. There's a problem with that. The British colonial rulers, they found out that people were doing this and they were none too happy. The program was costing them more money than they expected. So what did they do? Well, they were pretty short-sighted on this one too. They said, hey, we're going to stop paying for dead cobras. So the people who were breeding the cobras now no longer had a reason to breed cobras, and they let the cobras go. So now I have a real cobra problem. I have more cobras than I started with because of the way I incentivized the system. And that's the Cobra effect. Interestingly enough, on the Cobra effect, I haven't been able to find any real solid historical proof of it, which is kind of sad because it's a great story. If anybody finds it, send it my way, because I wasn't able to find it. I'm usually pretty good at Googling stuff. But the reason we call it the Cobra effect is that story was related to folks and economics. It is an actual term in economics. So I don't know if I've got anybody who studied economics here, but there is something called the Cobra effect in economics. And this is what the Cobra effect is. It's when people work with financial systems and incentives, and they try through financial incentives to get certain outcomes. But instead of getting the outcome that they desired, they get the opposite. That's the Cobra effect. That's the big part. And there's one more piece about the Cobra effect that's really important to understand is we have this, as human beings, we have this confirmation bias. We'll talk about biases later, but we have this confirmation bias. We want to think that things we're doing are working. And with the Cobra effect, things do work for a short period of time. So, I paid for dead cobras for a while. Looks like I'm winning. That's the term I would use. It looks like I'm winning. It looks like I made a good choice in the short run because the population goes down for a while until, people breeding cobras, and then they let them loose, and then I have a problem. So again, I do something in the system. I create some kind of incentive. I don't really think it through. And I see some immediate results, but then over time, I get the opposite effect. Okay, those are the elements of the Cobra effect. And they probably should have called it the rat effect, because even though I was unable to find historical information that this is actually true, they did have something. So we know Cobra effect stuff anyway, but there was something similar in Vietnam where they had rats and they had a rat problem. So what they did is they paid people to bring them rat tails, which is really strange to me. I mean, they should have incentivized them to bring at least an entire dead rat. But they paid them for bringing the tails, and all we did is we got people breeding rats, and we got a lot of rats running around without tails, right? So that one we know about. So let's talk about some real problems, and let's talk about systems thinking, and how sometimes if we don't use system thinking, we can have some things that go awry. So a big problem around the world is pollution, automobile pollution. 99.9% of scientists believe that it is human pollution that is causing global warming. Remember that when you're sweating today, because it's going to be hot all over the United States today. There are some ideas to solve automobile pollution. Here's one. This was in Mexico City. I think it was called Hoy no Circula. I don't have my notes in front of me, and I'm not good at Spanish. Anyway, it means today it doesn't circulate. What you can do is you can say, hey, look, let's take some cars off the road. And the way we're going to do it is we're going to say, if you have a certain license plate number, and it wasn't this, but you could think maybe odd and even days, right? If you got an odd license plate number, you can drive on odd days. If you got an even license plate number, you can drive on even days. Something like that. Let's restrict the number of days that somebody can travel. And that makes sense. But they didn't think that one through either, right? Because what actually happened, as you can imagine, is people didn't stop having to go to work. That's where most people are driving for the most part. They didn't have to stop going to work. They still had to go to work. So what do they do on the days that they can't go to work? Well, They might carpool or do something for a while, and a typical Cobra effect, the pollution in Mexico City went down during the first year of this program. However, people didn't like it. It's an inconvenience for them. So what did they do? Right? They buy a second car. They get a different license plate number. So that now I've got two cars. But not only do they buy a second car so that they're still driving on the days that they're not, quote unquote, supposed to drive, but are they going to buy a brand new, fuel efficient car? No, they're going to buy an old beater. They're going to buy an old car, an old junker that pollutes more. So what happened in Mexico City? I don't have the numbers in front of me because I'm in the office. I can't see my notes here, but it decreased the first year, and then after that, it steadily increased. So classic Cobra effect, right? Don't look at the entire system. Put in something that seems like it will work. It works for a while. Now I've got a bigger problem. Here's another thing we can do. We do this in the United States. We do this here in California. Let's create a carpool lane, HOV lane. Does it work? This is a little more controversial because we want it to work. That's one of the things we want it to work because it seems like a good idea. We don't get more people through the system when you create an HOV lane. Now I've got, I got to go from 5 lanes now that are really active to 4 lanes that are really active and one that's kind of active. And we know from queuing theory, when I reduce the number of servers, what happens? It takes longer. If it takes you longer to commute, you're gonna drive slower. And this is the big deal about pollution. If you drive fast, you don't pollute much. It's only when you're doing the start and stop thing like rush hour that we get the pollution problems. It didn't work. There's a study. So if you're curious about the study, you say, Larry, I don't believe you. That's fine. I've got it in the notes here. So I'm going to put this PowerPoint up when we're done here, as I always do on the presentation and recording channels. Check it out. This is a scientific study. It increased commute times and increased pollution, both, right? Again, classic Cobra effect. How do we avoid it? A couple of things we want to do. One, we need to understand systems thinking. We need to look not just at parts of the system. We need to look at the whole system, right? We need to think things through. We need to have multiple mental models. We have to have different lenses. We have different ways of seeing things. We need to actively court diversity of opinion. And this is really interesting because we don't, as a rule, as human beings, tend to do that. We tend to surround ourselves with people who think the same way we do, who look the same way we do. And that's not always a good thing, right? We need these mental models. Now, there are 2 ways to do this. One is you can have a class like this that talks about mental models explicitly and encourages individuals to get more mental models, to change the way they view the world, to get more lenses. You can also do that by hiring people with diverse backgrounds and experience. Either way. You can do it within the individual and you can do it within the group by diversity. Here's the other thing too, and this is the thing sometimes with government programs. We come up with the idea and then we create a blanket program. Best thing you can do, one of the best things you can do in the complex world by far, always assume that you could be wrong. Always assume you could be wrong. And so instead of coming up with a perfect plan and spending a lot of time coming up with a perfect plan and then implementing the perfect plan in a universal basis, pilot, try it in the small. How can I test this idea? How can I test to see if I'm right or wrong? And if I assume I'm wrong, I will be making the test to either prove that I'm wrong or not wrong. This is what science does. Science says, here's the hypothesis. Let us try to bring in every evidence that we can to prove the opposite or the null hypothesis, that this is not the case. That's not the way human minds work, by the way. We tend to think even that science says come up with an idea, a hypothesis, and then do whatever you can to prove it. That's not how it works. Assume that you've been wrong. Assume that you're wrong. There's a guy named Charlie Munger. Most of you haven't heard from if you haven't taken the class before. But I always get people's attention because you all know Warren Buffett and Berkshire Hathaway, and the fact that Warren Buffett is one of the world's richest people. Well, Charlie Munger is also one of the world's richest people, and probably half of the brains behind Warren Buffett. Just Warren Buffett is the more public figure. He came up with, and we're transitioning to a little bit about the cognitive illusions and biases that we'll talk about in the next class. He had his what he called practical wisdom before we knew what biases were. And he's got some really good quotes, but basically he says, we need to have, it reminds me of Deming. He says, we need to understand that we can't just learn facts. This is one of the problems we have. There's a lot of problems we have with education in the United States. One of them is we just teach people facts. Facts, that's no big thing. We need to teach people how to think, not what to think. You have to have some kind of framework to put these facts on, else they're just useless, right? They're trivia. And he refers to models. You have these models in your head. And you have to, he didn't call them mental models, he called it practical wisdom, but that's what he's talking about. You got to have these mental models, and you need to have a bunch of them. And you need to apply different ways of looking at the world. It's like the old saying, this is a quote from a talk, and we're going to hear Munger in a second. He says, the man with a hammer, everything looks like a nail. If you only have one way of looking at the world, you're going to torture the world to match your worldview, and you're not going to change your worldview to match the world. That's not the way the human brain works. It's the way it should. Anyway, he talks a little bit about mental models. I want to move into, he had a bunch of them. He has 20 different things that he identified as different ways of looking at the world, different mental models, different lenses. And it worked really well for him, didn't it? I mean, he was able to apply these mental models, and the reason I use it is he applied them in the financial world. And what happened? He became a billionaire. You could say he became lucky, but I would say there's more to it. We want to hear from, this is Charlie right here. We want to hear from Charlie. He gave a talk. He doesn't talk much in public. He gave a talk to, I don't know which one it was. It's either Harvard, or for some reason, I'm thinking Marshall School of Business down at USC. Either one. It was for a graduation, where he talks about his psychology of human misjudgment, which is basically this concept of mental models and incentives, etc. Here we go.
I am very interested in the subject of human misjudgment, and Lord knows I've created a good bit of it. I don't think I've created my full statistical share, and I think that one of the reasons was that I tried to do something about this terrible ignorance I left the Harvard Law School with. When I saw this patterned irrationality, which was so extreme, and I had no theory or anything to deal with it, but I could see that it was extreme, and I could see that it was patterned. I just started to create my own system of psychology, partly by casual reading, but largely from personal experience, and I used that pattern to help me get through life. Fairly late in life, I stumbled into this book, Influence, by a psychologist named Bob Cialdini, who became a super tenured hotshot in a 2,000-person faculty at a very young age. And he wrote this book, which has now sold 300,000 copies, which is remarkable for it's an academic book aimed at a popular audience. And that filled in a lot of holes in my crude system. And when those holes had filled in, I thought I had a system that was a good working tool. I'd like to share that one with you. First, under recognition of the power of what psychologists call reinforcement and economists call incentives. Well, you say everybody knows that. Well, I think I've been in the top 5% of my age cohort all my life in understanding the power of incentives, and all my life I've underestimated it. And Never a year passes before I get some surprise. Some of my favorite cases of power of incentives is the Federal Express case, where heart and soul of the integrity of the system is that all the packages have to be shipped rapidly in one central location each night. And the system has no integrity if the whole ship can't be done fast. And Federal Express had one hell of a time getting the thing to work. And they tried moral suasion, they tried everything in the world. And finally somebody got the happy thought that they were paying the night shift by the hour. And that maybe if they paid them by the shift, the system would work better. And lo and behold, that solution worked. Early in the history of Xerox, Joe Wilson, who was then in the government, had to go back to Xerox because he couldn't understand how their better new machine was selling so poorly in relation to their older and inferior machine. Of course, when he got there, he found out that the commission arrangement with the salesman gave a tremendous incentive to the inferior machine. Fourth, and this is a superpower in error-causing psychological tendency, bias from consistency and commitment tendency, including the tendency to avoid or promptly resolve cognitive dissonance, includes the self-confirmation tendency of all conclusions, particularly expressed conclusions, and with a special persistence for conclusions that are hard-won. Well, what I'm saying here is that the human mind is a lot like the human egg, and the human egg has a shut-off device. When the sperm gets in, it shuts down so the next one can't get in. The human mind has a big tendency of the same sort. And here again, it doesn't just catch ordinary mortals, it catches the deans of physics. According to Max Planck, the really innovative, important new physics was never really accepted by the old guard. Instead, a new guard came along that was less brain-blocked by its previous conclusions. And if Max Planck's crowd had this consistency and commitment tendency that kept their old conclusions intact in spite of disconfirming evidence, you can imagine what the crowd that you and I are part of behaves like. And of course, if you make a public disclosure of your conclusion, you're pounding it in to your own head. Many of these students that are screaming at us, they aren't convincing us, but they're forming mental chains for themselves because what they're shouting out, they're pounding in. And I think educational institutions that create a climate where too much of that goes on are, in a fundamental sense, they're irresponsible institutions. It's very important to not put your brain in chains too young by what you shout out. And all these things like painful qualifying and initiation rituals, and all those things pound in your...
Sorry about it. He's getting towards the end. Basically, what he's saying here is that we have these certain mental models and things that we use. And a lot of these mental models are things that we form very early. And we shut other things out because we're not looking for the truth. We're looking to be right. And that's a different thing. Give you some other sources when we talk about mental models and other things. There's one person, his name is Shane Parrish. He has a blog called Farnham Street. It's a great blog, by the way, and I have a link here. He attacks mental models directly and head on, and labels them and talks about them and how do we achieve, what are they and how do we get more of them, and how do we train ourselves? So he has 125 different mental models. Munger had 20. I don't know how many there are out there, at least 125, I suppose. He's taken some of that work and he's put it into some books, which are on the right side here. I've read both of the books. They're good books to understand. Look, there's so many different lenses and models and ways of looking at the world. The more of them that we have, the more accurate we're going to be with objective reality. So I wanted to present that. And again, the presentation will be available so that people can follow up on those. I have one more video, which we all like, talking about general thinking concepts and models and how we behave as human beings. The interesting thing about this video that you'll see is I want you to notice how all of the participants in this small little experiment, or whatever you want to call it, a demonstration, very consistent in how they approach the problem. Because we as humans have certain mental models and we apply them pretty much in similar ways. So I'm going to let this one play. Hang on.
I'm going to give you guys three numbers, a three-number sequence, and I have a rule in mind that these three numbers obey. And I want you to try to figure out what that rule is. But the way that you can get information is by proposing your own set of three numbers, to which I will say yes, that follows my rule, or no, it doesn't follow my rule, and then you can propose what you think the rule is. Is that fair?
Yeah.
Yeah. Okay, so here are the three numbers. 2, 4, 8.
2, 4, 8.
You don't need to continue the sequence. You can propose a totally different sequence, whatever you want to propose, and I will simply say yes or no. That follows my
2, 4,
rule.
8. 16, 32.
16, 32, and
64.
those also follow my rule.
Okay.
What's the rule? What do you think?
Multiply by 2.
That is not my rule.
What?
That's not my rule. But you're allowed, if you want, propose three other numbers.
3, 6, 12.
3, 6, 12.
3, 6, 12 follows my rule.
10, 20, 40.
10, 20, 40.
That follows the rule.
Yeah, I'm still multiplying by 2.
I know.
Oh.
I know what you're doing. And yes, it follows my rule, but no, it's not my rule.
5, 10,
10 and 20.
Follows my rule.
100,
200. 400.
Follows my rule.
500, 1,000, 2,000.
Follows my rule.
Want me to keep going?
But do I just keep going? You're going to tell me your rule?
Am I doing it the wrong way? Am I approaching this the wrong way?
You're totally fine,
Okay.
but you're approaching it the way most people approach it. Like, think strategically about this. You want information.
Yeah.
I have information. The point of the three numbers, right, is to allow you to figure out what the rule is.
Okay.
Okay, I'm going to give you the numbers that I don't think fits a sequence and then see what you say. So I'll say 2, 4, 7.
Fits my rule.
So whatever I propose is right?
So is your rule like you can propose any number?
So the rule is anything we say is yes.
No.
Damn it.
But you are on the right track
Okay.
now. Hit me with three numbers.
3, 6, 9.
Follows my rule.
Oh, that didn't follow my rule.
This is good, right?
5, 10, 15.
That follows my rule.
What? Oh. Really?
Yeah.
I don't believe this.
1, 2, 3.
1, 2, 3.
Follows the rule.
What about 7, 8, 9?
Follows. Yes, that follows the rule.
8, 16, 39.
Fits the rule.
Excellent.
But we're no closer to the rule. I want you to get to the rule. How about 1, 7, 13? Follows the rule.
What?
11, 12, 13.
How does this
Follows
make
the rule.
sense?
10,
I don't
9,
know how to
8
do this.
Does not follow the rule. 10, 9, 8 does not.
Oh, so is it all in ascending order?
Booyah.
Okay.
Up top. Yes, first
that
ones
what
to
it
get it. You guys nailed it. That's the rule. That's the rule. Increase numbers in increasing order. Numbers in ascending order.
Oh, so much.
1, 2, 3, 4, 5, 6, 10, 15, 25. Doesn't matter. Any numbers in ascending order. I was inspired to make this video by the book The Black Swan by Nassim Taleb. Now, the black swan is a metaphor for the unknown and the unexpected. I mean, in the old world, the theory was that all swans were white. So each instance of a white swan would make you think, yeah, that theory's pretty good. But the point is, you can never prove a theory true. And in fact, when people found Australia, they realized that there were black swans. What was interesting for me was that everyone I spoke to came up with a rule very early on and then only proposed numbers that fit with that rule they were thinking. I was looking for you guys to propose a set of numbers that didn't follow your rule
Right.
and didn't follow my rule. I was looking for you guys not to try to confirm what you believe. You're always asking something where you expect the answer to be yes, right? Like you're trying to get at it. Yeah.
But instead you want to get the no.
You want to get the no because that's much more informational for you than the yes. Like if everything's
No, that
giving a
is
yes.
true. That is really true once you say that.
That is what's so important about the scientific method. We set out to disprove our theories. And it's when we can't disprove them that we say, this must be getting at something really true about our reality. So I think we should do that in all aspects of our lives. If you think that something is true, you should try as hard as you can to disprove it. Only then can you really get at the truth and not fool yourself.
Okay, some of you have seen that before. It was pretty interesting. And there is, though I know this is simplistic because somebody will probably put it in chat. There's a neurological basis for this. There's an evolutionary basis for this, for reinforcing us being right. This is why I believe that people watch certain news shows that get them all fired up about the world because they have a certain worldview that agrees with that. So they may be angry, but they also feel right. We have this mechanism in our brains, and again, simplistically, I believe it's mostly the dopaminergic pathways, dopamine, which is triggered when we're right, when we have a view of the world, and then we're proven right, and we seek that out because dopamine is a highly addictive neurotransmitter. It's what's indicated in drug abuse and alcohol abuse and OCD and other behaviors that are we would probably not consider optimal behaviors. We are wired for it. We're not wired to be scientific. We're not wired with a lot of mental models. And most of the time, it's okay. Most of the time, it's okay. Most of the time, you can get along in your life and not have to see things clearly. But I'm going to go back to the metaphor I used on day one. If you need to, if you need glasses to drive, most of the time you drive, you're not going to hit anything. It's going to be okay. You're going to be able to see if the sun is out there and it's great and whatever. But what happens at night? What happens when it rains? Right? Can you see as well? No, you don't see as accurately. And then it becomes a problem. It's not always a problem. It's become a problem, and people say I'm too political, but it's become a problem. It doesn't matter which side you're on. I'm from San Francisco. You know what side I'm on. But it's become a problem in politics because we don't even agree on the facts anymore. We cannot see through this world that we've created. And when, we feel good about it, we're righteous about it. And that's not the way the world should be. If we wish to be optimal in this world as individuals and as organizations, as companies, et cetera, as societies, we have to start seeing the world differently. We have to be able to pick up these different lenses and try to view the world differently. It's imperative that we do so. But we're not built that way. So we built, we as human beings have built a complexity into the world that didn't necessarily exist. I mean, in some ways it did, but we built it and we can't handle it a lot of times. And this has some huge implications as far as us as human beings. So again, how do we attack these things? Well, we need to have these different lenses. We need to have these different mental models. We have to have different ways of seeing the world. It's not that one is more accurate in some cases than others. It's that each one of those gives us a view of reality that we didn't see differently. I was thinking about it, I want to keep coming back to this, naked eye versus a telescope versus a microscope. You can look at the same things through those different lenses. The thing itself doesn't change. The view is not inaccurate, but the view only gives you a piece of reality. There's no way to know as human beings the totality of what exists outside of our experience. We have no way of knowing. I mean, it's like those old brain teasers. How did the world even exist before you were part of it? Well, you don't know. You have no way of knowing. You only have what you experience. And that's the way it is. And we don't always experience it very clearly, which is the subject of the next talk, which is on cognitive biases.